Bismillahirrahmanirrahim. Welcome to another video. This is Hamza Noor from Aero Education Network, and this is basically a follow-up lecture for the past papers of International A-Level Edexcel P1 Pure Mathematics 1. The topic is straight line graphs. We are doing past paper questions from the past paper handout. In my previous video, I discussed three questions, which was the question number 3, question number 6, and question 10 of the handout. So you can find the link of the previous video in the description of this video as well, or maybe the pinned comment. Okay, so now we have question number 14, which is June 2012, C1, question number 9. Okay, so the question says that the line L1 has equation 4y plus 3 is equals to 2x. The point A is P comma 4, which lies on the line L1. The requirement of part A is to find the value of the constant P. So what we know the fact is that point A, which is P comma 4, it satisfies the equation of the line L1. So what we are going to do, we are going to substitute x is equals to P into the equation, and the corresponding value of y will be 4. So 4 times 4 plus 3 will be equals to 2 times P, since the point P comma 4 is on the line L1. Okay, so 16 plus 3 is 19, so 19 is equals to 2p. Therefore P is equals to 19 divided by 2. Either you can write your answer 19 over 2, or you can simply say 9.5. Okay, this is supposed to be your answer. Okay, so in part B, it says that the line L2 passes through the point C, which is 2 comma 4, and is perpendicular to the line L1. The requirement of part B is to find an equation for L2. Okay, we need to find the equation for L2, giving the answer in the form of AX plus BY plus C is equal to 0, where A, B, and C are integers. All right, so what we know the fact is that L1 is perpendicular to L2. Okay, so when the lines are perpendicular to each other, the product of their gradients is equals to -1. Okay, so therefore we are going to say that the gradient of the line L1 multiplied by the gradient of the line L2 is -1. So what we know is that the equation of the line L1 is 4y plus 3 is equals to 2x. So I'm going to rearrange this equation in the form y is equals to mx plus c. So 4y is equals to 2x minus 3. Therefore y is equals to 2 over 4 into x minus 3 over 4, meaning the gradient of the line L1 is half, because y is equals to half x minus 3 over 4 is the equation of the line L1 in the form y is equals to mx plus c. So the gradient of the line L1 is basically half. Okay, and since L1 and L2 are perpendicular to each other, therefore half multiplied by the gradient of the line L2 is -1. Therefore the gradient of the line L2 is -2. All right. So in the question, it is said that point C lies on the line L2. So when we are supposed to find the equation of the line L2, this means that the gradient of the line L2 is -2, and it passes through the point C, which is given to us 2 comma 4. Okay, so we are going to use this form of the line y minus y1 is equals to m multiplied by x minus x1, meaning y minus 4 is equals to -2 multiplied by x minus 2. Okay, so y minus 4 is equals to -2x plus 4, meaning y plus 2x minus 4 is equals to 0. And we need a specific form, which is ax plus by plus c is equals to 0, where a, b, and c are integers. Okay, so therefore the equation of the line is 2x plus y minus 8 is equals to 0. This is the answer of part B as per the requirement of the question. We have expressed our answer, the equation of line L2, in the form 2x plus y minus 8 is equals to 0. So this was the working for part A and part B. So now let's move on to part C. So before part C, we have some information that the line L1 and the line L2 intersect at the point D. Find the coordinates of the point D. Okay, so as simple as that, we know the equation of the line L1 in the question, and as far as L2 is concerned, we have found the equation in part B. So what we are going to do, we are going to simultaneously solve these two linear equations in order to find the coordinates of the point D, because D is the point of intersection between the line L1 and L2. So I'm going to simultaneously solve these equations. Okay, so as far as L2 is concerned, so I'll express the equation in the form y is equals to mx plus c. So y is equals to 8 minus 2x, and I'm going to substitute it into the equation of the line L1, and equation of the line L1 is 4y plus 3 is equals to 2x. So 4 times 8 minus 2x plus 3 is equals to 2x, meaning 32 minus 8x plus 3 is equals to 2x. So therefore 32 plus 3 is 35, and 35 is equals to 2x plus 8x, which is 10x. So x is equals to 35 divided by 10, meaning the x coordinate of point D is 3.5. X is equals to 3.5, and the corresponding y coordinate is 4y plus 3 is equals to 2 times 3.5. So 4y is equals to 7 minus 3, meaning y is equals to 4 divided by 4. Y is equals to 1. Therefore, the coordinates of D are 3.5, comma 1. This is supposed to be your answer to part C. Okay, so we solved these two simultaneous linear equations in order to find the point of intersection, which is point D. All right, so now let's move on to the next part. All right, so for part D and onwards, I'll bring the picture of the question on the next page. Okay, so the requirement of part D is to show that the length of the line CD is 3 over 2 multiplied by root 5. Okay, so point C was given to us in the question, 2 comma 4, and point D we found in the earlier part, 3.5 comma 1. Okay, so we need to find an exact form for the length of the line CD. All right, so the magnitude of the line CD, meaning the distance between point C and point D, under root of x2 minus x1 whole square plus y2 minus y1 whole square. So magnitude of the line CD is under root of 3.5 minus 2 whole squared plus 1 minus 4 whole squared. Okay, so this means that under root of 1.5 square plus minus 3 whole squared. So inside the under root we will have 45 over 4. 1.5 square plus minus 3 whole squared is 45 over 4. So under root of 45 over 4 is exactly the same thing as saying under root 45 divided by under root of 4, and under root 45 is under root 9 multiplied by under root 5, and under root 4 is 2. So 3 over 2 multiplied by root 5 units. This is supposed to be your answer to part D. Okay, we need to show the length of the line in an exact form, 3 over 2 multiplied by under root 5. So now let's move on. Here we have some information. A point B is on the line L. It lies on the line L1. Point B lies on the line L1, and the length of AB is under root of 80. Okay, and point E lies on L2 such that the length of the line CDE is 3 times the length of the line CD. The requirement of part E is to find the area of the quadrilateral ACBE. All right. So what we know the fact is that uh, as much as information we have in the question, and as far as the things which we have found from part A till part D, what we can do, we can make a sketch. Okay. So the best way is to make a sketch first of all of the information which you have in the question and all of the information which you have gathered by attempting all of the previous parts. So what I know the fact is that point A is on the line L1, okay, and the gradient of the line L1 was half, okay, and the y-intercept was minus 3 over 4, and L2 was perpendicular to L1, okay, and point D was basically the point of intersection between L1 and L2. Okay, so let's just consider this much piece of information. Point A is, let's say, point A was P comma 4, right? And the value of P was 9.5. So here is basically point A. Okay, and since point A was on the line L1, so L1 is having a gradient of half. So L1 is an upward sloping line. Okay, so this is the line L1. All right, and then L2 is perpendicular to L1. All right, and the point of intersection between L1 and L2 is point D, which we found 3.5 comma 1. 3.5 comma 1 was the point of intersection between L1 and L2. And what we also knew the fact that point C is on the line L2, okay, and C is 2 comma 4. Okay, so the x coordinate of C is smaller than the x coordinate of D, and since the y coordinate of point A is also 4 and y coordinate of point C is also 4, okay, so this means that AC is a horizontal line. Point C and point A are on the same horizontal line. So let's say point C is over here, 2 comma 4. This makes sense, okay? And we have also shown that the length of the line CD is 3 over 2 into under root 5. So length of the line CD is 3 over 2 times under root 5. Okay, this is the length of CD. And the length of AB is under root of 80. And we don't know where the point B is actually. So the length of AB is basically under root of 80. So let's say somewhere over here I've made point B. I don't know the exact location of point B right now. Okay, what I know the fact is that AB is basically under root of 80, and if you put under root 80 in your calculator, this is 4 root 5. Okay, so you can write that the length of AB is, either you can write 4 root 5 or you can write under root of 80. So the length of AB is basically under root of 80, or you can simply say 4 root 5. Okay, and then what we also know that point E is on L2 such that the length of the line CDE is 3 times the length of the line CD. Okay, so the length of the line CD is 3 over 2 root 5. So the length of the line CDE is 3 times of 3 over 2 times under root 5. So here you can do some piece of working that the length of the line CDE is 3 times the length of the line CD, and CD length is 3 over 2 times under root 5. So this is supposed to be 4.5 root 5, meaning 9 over 2 multiplied by under root 5. This is the length of the line CDE. Okay, so point E would be somewhere over here. All right, this makes sense because this complete length would be 4.5 times under root 5. 9 over 2 into under root 5 units. So what we want the area of the quadrilateral ACBE over here. So I'm going to just connect these points. Okay. So we will have a four-sided figure ACBE, and we need to find its area. We'll just connect the lines accurately. This is fine. Okay. This is a four-sided figure ACBE. Okay, so we want the area of this four-sided figure. So what we can see is that we know the base of this triangle ABC, which is under root of 80, and the height of this triangle is 3 over 2 times under root 5. So half into base into height, we would be easily able to calculate the area of this triangle ABC first. And then we are going to use the same base AB length, which is under root 80, which was given to us in the question, and we can find the height of this triangle, which is DE length, by considering the ratio over here. Okay, and we would be able to find the area of the triangle ABE. Okay, and then we will add up these two areas, and then we would be able to calculate the area of this four-sided figure. As simple as that. Okay, I'm just going to make a smooth line over here. All right, that's fine. थोड़ा सा हिल गया, हाँ. I'm going to just connect this broken line with a smooth line. All right, so in order to find the area of the quadrilateral ACBE, okay, we need the area of this triangle ABC and the area of this triangle ABE. Okay, we know the height of this triangle CD, which is 3 over 2 into under root 5, and we have found the length of the line CDE by using this ratio 3 times the length of line CD. So the length of CDE is 4.5 root 5, meaning 9 over 2 multiplied by under root 5. Okay, so in order to find the height of this triangle ABE, the height of this triangle is DE, the perpendicular length. Okay, so what I'm going to do, in order to find the length of the line DE, I'm going to subtract CD from CDE. So DE length is CDE minus CD, as simple as that. Okay, from CDE, we are subtracting this length CD in order to get the height of this triangle, which is DE. Okay, so 4.5 root 5, meaning 9 over 2 into under root 5 minus 3 over 2 times under root 5. So 4.5 minus 1.5, this is 3. So DE length is 3 root 5 units. Okay, this is the length of the line DE. Now, in order to find the area of the quadrilateral ACBE, area of the shape ACBE, what you need to do, first you find the area of triangle ABC, and then plus area of triangle ABE. Okay, so in order to find the area of triangle ABC, half into base into height, meaning half multiplied by AB length multiplied by CD length, and then plus, in order to find the area of triangle ABE, half multiplied by base into height. So base is the length of AB, okay, and the height is DE for this triangle, which we have also found by the working by using the ratio. Okay, so half multiplied by under root of 80 multiplied by 3 over 2 root 5. Okay, and then plus half multiplied by under root of 80 multiplied by DE. DE is 3 root 5. So far we have achieved this thing. You just need to find, you just need to evaluate these values. Okay, so under root 80 is 4 root 5, and 4 root 5 divided by 2 is 2 root 5. So 2 root 5 multiplied by 3 over 2 root 5 plus under root 80 is 4 root 5 divided by 2. This is 2 root 5. So 2 root 5 times 3 root 5. Okay, so 2 root 5 multiplied by 1.5 root 5. This is 15. Okay, and 2 root 5 multiplied by 3 root 5, this is 30. So 15 plus 30, 45 units square is your answer. This is basically the area of the quadrilateral ACBE which was required. This was the requirement of part E. All right. So in this way, you can attempt this part E by considering a complete sketch. And in order to make a sketch, okay, in order to make a reasonable sketch, you need to use all of the information which was given to you in the question and all of the information which you found in the earlier parts. Okay, so this is how you attempt this particular question. Alternatively, what we can do is we can find the area of this quadrilateral by shoelace shoestring method. And for that purpose, we would need the coordinates of B as well and coordinates of E as well. Okay. And area by shoelace shoestring method, I've explained the detailed concept in my previous video. Okay. And I've applied it to all of the questions over there. So in the same way, I'll discuss the area by shoelace shoestring approach over here. The main thing is to find the coordinates of B and E. Okay, so I'll do the working on the next page for part E, alternative method, area by shoelace shoestring approach, shoelace shoestring method. Area by shoelace shoestring method, shoelace or shoestring method. Okay, so first thing is that we need the coordinates of B and E. We know the coordinates of A and C over here. Okay, what we know the fact is that AB is an upward sloping line. Okay, and we know the length of the line AB. Okay, AB is an upward sloping line, which is line L1, which is having a gradient of half. Okay, and the coordinates of A are P comma 4, meaning 9.5 comma 4. Okay, and the length of the line AB is under root of 80. The distance between A and B is under root of 80, which is 4 root 5 units. Okay, so the length of the line AB is 4 root 5 units. All right. So what we know the fact is that if we just consider the concept of the gradient is basically change in y over change in x. The gradient of this line is 1 over 2, meaning when the change in x is 2 and change in y is 1. Okay, so let's say if I move from point A like this, that the change in x coordinates is 2 and the change in y coordinates is 1. So I'm moving on the left hand side. I'm moving horizontally on the left and vertically towards down. So I'm going to say that the change over here is -2 and here we have -1. So therefore I would be able to say that the gradient of the line is -1 divided by -2, which is supposed to be half. We have a positive gradient. Okay, you just consider the concept of the vectors. Okay, just have an idea of the vectors approach, that in order to move along the line, because in order to move along the line to reach point B, I have to come along the line towards down. Okay, so I'm considering the vector like this, that change in x is -2 and change in y is -1. But when you consider a small piece of triangle over here in which the change in x is -2 and change in y is -1, so what would be the hypotenuse? Under root of -2 whole square plus -1 whole square, meaning under root of 4 plus 5, which is under root 5. Okay, but we need the hypotenuse to be 4 root 5 because distance between A and B is under root 80, which is 4 root 5. Okay, so when you multiply the hypotenuse with 4, so obviously the change in x coordinate and the change in y coordinate will also be multiplied by 4. Make sense or not? So what I'm trying to tell you is that in order to move from point A to point B, okay, in order to move from point A to point B towards left, you need to come 4 times minus 2. Okay, in order to come from point A to point B, you need to go 4 times minus 2 towards left, and basically 4 times minus 1 downwards, so that you would be able to say that from point A you can reach point B. Make sense or not? As simple as that. So this means that since the coordinates of A are known to you, which you have already found in part A, okay, and the change in x coordinates is minus 8 and change in y coordinates is minus 4. So when you use minus 4 divided by minus 8, meaning change in y over change in x, so the gradient is supposed to be a half. And as you know that the gradient of the line AB is half. Okay, as simple as that. So basically, in order to move from point A to point B, you need to use this vector. Okay, I'm going to use this, that the change in x coordinates is 4 times minus 2, which is minus 8, and change in y coordinates is 4 times minus 1, which is minus 4. Because when you consider the triangle in this way, that the change in x coordinates is minus 8 and change in y coordinates is minus 4, so the hypotenuse would be 4 root 5. Okay, meaning under root of minus 8 whole squared plus minus 4 whole squared. Okay, meaning under root of 64 plus 16, which is under root of 80, which will give you 4 root 5. Okay, so this working is extra, it is just for your understanding. All right, so in order to move from point A to point B, so point B would be achieved in this way, that 8 is subtracted from the x coordinate of point A, okay, and 4 is subtracted from the y coordinate of point A. So therefore, point B is 1.5 comma 0. Point B is on the x-axis. Point B is 1.5 comma 0. We have found point B. All right. And now in the same way, I'm going to find the coordinates of E. And as we know the fact that the length of the line CE, this complete CE length is basically, CDE length, which is 4.5 root 5, which we have already found, meaning 9 over 2 multiplied by root 5. Okay, so I'm going to find it over here. So I'm going to draw the line CE now. Okay. So point C was given to us in the question. It was 2 comma 4, and CE is basically the line L2, and the gradient of the line L2 is minus 2. Okay, since L1 and L2 were perpendicular to each other. All right, and the length of the line CE is 9 over 2 multiplied by under root 5, meaning 4.5 times under root 5. I'm just going to write 4.5 times under root 5 over here. All right, so basically the gradient of the line is minus 2. So if you consider the change in x coordinates and y coordinates, so when the gradient is minus 2, this means that change in y over change in x is minus 2, meaning minus 2 divided by 1. So when the change in y is minus 2, change in x is 1. So when change in x is 1, okay, so change in y is basically minus 2. Okay, in order to move from point C, okay, we need to go in this path, right? Along the line towards down. So change in x coordinates is positive, whereas the change in y coordinates is negative. All right. So when you consider this triangle in which change in x coordinates is 1 and change in y coordinates is -2. So what would be the hypotenuse? Under root of 1 is square plus -2 square, meaning under root 5. But we need the hypotenuse to be 4.5 times under root 5. Okay. So now in order to make the hypotenuse 4.5 times under root of 5, the change in x coordinates will be multiplied by 4.5, and in the same way change in y coordinates will also be multiplied by 4.5. Okay, the same thing, the ratio, because this triangle and this triangle, these two triangles are similar to each other, isn't it? This is basically the concept behind this. This is a small triangle and this triangle is basically similar to each other. So when hypotenuse is multiplied by a constant, so the remaining two lengths should also be multiplied by the same constant, isn't it? So in order to come from point C to point E, in order to come from point C to point E, what we want is that the change in x coordinates will be now 4.5 times 1. Okay, and the change in y coordinates will be 4.5 times -2. I've made a very rough sketch. It is not according to a scale. Okay, I just need to calculate the coordinates as soon as possible so that we can find the area by shoestring method. All right, so C, the coordinates of C were 2, 4, and we are coming from point C to point E. So in order to arrive from point C to point E, the change in x coordinates is now 4.5 times 1, which is 4.5, and the change in y coordinates is 4.5 times -2, which is -9. Okay, and we would be able to say that the gradient of the line CE is, -2, because change in y over change in x would be -9 divided by 4.5, which is -2. So the gradient of the line L2 is, -2, as we already know this thing. So the calculation of the coordinates of E would be that 4.5 will be added in the x coordinate of C. So 2 plus 4.5. Okay. And the y coordinate of E will be obtained in this way, 4 minus 9. As simple as that. So therefore, the coordinates of E are 6.5, comma, -5. Okay, so we have successfully found point B and point E. And now the moment of truth, area by shoestring method. We will get the same answer which we obtained from the earlier part. I just need to box this up. Okay. So coordinates of E are 6.5, comma, -5. So we are going to find the area of this four-sided figure, the quadrilateral ACBE. So ACBE, remember the sequence, okay? I'm just going to bring the sketch. And as far as the sketch is concerned, it was just required for the previous method. It is not actually required for this shoestring method. So that's fine if we don't bring the sketch over here. We don't actually need it. So area by shoestring method, meaning half multiplied by, first you make the modular sign, x1, y1, x2, y2, x3, y3, x4, y4. Okay, because this is a four-sided figure, and then x1, y1 again. Okay, so just remember the sequence. ACBE. We are finding the area of ACBE. Okay, even you can say AEBC, that's also fine. But when you are considering this ACBE, so you are starting from A, then you are going up till C, then B, and then E. And then you will write the starting point A again. That's all of the detail I've explained in my earlier video. I'll also mention the link of the earlier video which I'm talking about. Okay, you can see that video as well in order to get the complete understanding of this particular method. Okay. The main thing over here was the calculation of the coordinates of B and E. I hope this working is clear, which is very simple. Okay, you just need a lot of practice for this. All right. So I try to explain things in as much detail as possible. okay, to keep things fair. All right. So starting from point A, so half multiplied by, first you make the modular sign. Point A was, first you write the point A. All right. Then point C. Point C was 2 comma 4. C was 2 comma 4. Then point B, we have found 1.5 comma 0. Okay. And then point E, 6.5 comma minus 5. All right. And then point A again in the end. And then you close the modulus sign. And now you know what you need to do. First of all, you follow this sequence: x1 y2 plus x2 y3 plus x3 y4 and then x4 y1. All right, so area is equals to half multiplied by what? First you make the modulus sign and then x1 into y2, okay, multiply these coordinates, 4 multiplied by 9.5. This is 38, okay, 38, and then 2 times 0. All right, so 2 times 0 is 0. And then 1.5 times minus 5. So 1.5 times minus 5. This is minus 7.5. Okay. And then 6.5 times 4. So 6.5 times 4, this is supposed to be 26. And then the bracket is closed. And then the subtraction sign. And then the opposite zigzag pattern like this: x2, y1, x3, y2, x4, y3, x1, y4. Okay. So 2 times 4, 8, and then plus 1.5 times 4. Okay, so 1.5 times 4 is 6. So 8 plus 6. And then 6.5 times 0. So this is 0. Okay. When things become 0, it looks very good, right? It looks simple. So minus 47.5 in the end. All right. And then you close the modulus sign. Okay, so area will be 45 units. So 38 minus 7.5 plus 26. This is 56.5, and minus 8 plus 6 minus 47.5. This is minus 33.5. Okay, so 56.5 plus 33.5. Okay, so area is equals to half multiplied by modulus of 90, which means half multiplied by 90, which means 45 units square. Okay, so we have obtained the area by shoelace shoestring method. The actual thing was the calculation of coordinates of B and E. Okay, this method is really helpful. At times you would need this method more often. Okay, so you need to have a complete understanding of this. Okay, here, if I just mention the arrows over here as well, that in order to come from point C to point E, we were going in the positive x-axis and the negative y-axis in the same way which I have marked the arrows over here. This is simply just vectors approach, okay? Nothing else. Simple mathematics. All right, so this was a complete solution of this question, which is June 2012, C1, question number 9. All right, this was question number 14 of the handout. Now let's move on to the next question. So the next question is question number 20 of the handout, which is June 2017, C1, question number 8. All right, so the question says that the straight line L1 shown in figure 1 has equation 5y is equals to 4x plus 10. The point P with x coordinate 5 lies on line L1. Okay, this is line L1 and point P is over here with x coordinate 5. The straight line L2 is perpendicular to L1, okay, and passes through P. So the requirement of part A is to find an equation for L2 and we need to write our answer in the form ax plus by plus c is equals to 0, where a, b, and c are integers. So first thing first, what we know the fact is that the equation of line L1 is 5y is equals to 4x plus 10. So this means when y is made the subject, so y is equals to 4 over 5 into x plus 10 over 5, meaning the equation of line L1 is y is equals to 4 over 5 into x plus 2. This means that when we make a comparison with the form of y is equals to mx plus c, so the gradient of line L1 is 4 over 5. This is the gradient of line L1. Okay, and point P is having x coordinate 5. So I'm going to just substitute this x coordinate 5 into the equation of the line L1. So y is equals to 4 over 5 into 5 plus 2, meaning y is equals to 4 plus 2, which is 6. So therefore the coordinates of P are 5, 6. We need to find the equation of line L2, and L1 is perpendicular to L2, and point P is on the line L2 as well. Okay, so since L1 is perpendicular to L2, so this means that gradient of line L1 multiplied by the gradient of line L2 is -1. Okay, and the gradient of line L1 is 4 over 5. So 4 over 5 multiplied by the gradient of line L2 is -1, which means gradient of line L2 is -5 divided by 4. So far we have achieved this much. So when we are supposed to find the equation of line L2, okay, so the gradient of the line is -5 over 4, and it passes through the point P, which is 5, 6. Okay, so we are going to find the equation of line L2. So y minus y1 is equals to m multiplied by x minus x1, meaning y minus 6 is equals to -5 over 4 multiplied by x minus 5. So 4 multiplied by y minus 6 is equals to -5 multiplied by x minus 5, meaning 4y minus 24. 4 times 6 is 24, so 4y minus 24 is equals to -5x plus 25. So 4y plus 5x minus 24 minus 25 is equal to 0. So therefore 5x plus 4y minus 49 is equals to 0. We have expressed our answer in the form of ax plus by plus c is equals to 0 as per the requirement of the question. All right, so this is the equation of line L2, which is 5x plus 4y minus 49 is equals to 0. So this was the requirement for part A. So now let's move on to part B. And for that purpose, I'll bring the question on the next page. So we have the information that the lines L1 and L2 cut the x-axis at the points S and T respectively as shown in figure 1. Calculate the area of triangle SPT. Okay, so by using the equation of line L1, we will find the coordinates of S, since this is the x-intercept of line L1. And in the same way, we are going to find the coordinates of T, meaning T is the x-intercept of line L2. Okay, once we are able to find the coordinates of S and T respectively, we would be able to find the base of this triangle ST, okay, which will be simply the change in x coordinates. And height of the triangle we have already found, because the y coordinate of P was 6. P was 5, 6, meaning the y coordinate of P was 6. So height of the triangle is 6. So we can just simply use a sketch. All right. So what we can say is that S is basically the x-intercept of the line L1, and the equation of line L1 is 5y is equals to 4x plus 10. So I'm going to substitute y is equal to 0 over here. So 5 times 0 is equals to 4x plus 10, meaning x is equals to minus 10 divided by 4, meaning x is equals to minus 2.5. So therefore the coordinates of S are minus 2.5 comma 0. Coordinates of S are minus 2.5 comma 0. Now in the same way, we are going to find the coordinates of t by using the equation of the line L2, and the equation of the line L2 was 5x plus 4y minus 49 is equals to 0. 5x plus 4y minus 49 is equal to 0, and we are going to substitute y is equal to 0 over here. So 5x plus 4 times 0 minus 49 is equal to 0, meaning x is equals to 49 divided by 5. So 49 divided by 5, this is how much? This is 9.8. So therefore we are going to say that the coordinates of t are 9.8 comma 0. Okay, so the base of the triangle is basically ST, and ST is basically the change in x coordinate. So we can say that the length of ST is x coordinate of t minus x coordinate of S. Okay, because ST is the horizontal line. So the length of ST is 12.3 units. Length of ST is 12.3 units. So therefore we are going to say that area of triangle SPT is half into base into height, meaning half into ST multiplied by the y coordinate of point P. Because y coordinate of point P, which is 6, this is the height of the triangle. Okay, so this is the thing. So y coordinate of P is basically 6, which is the height of the triangle. So therefore area of triangle SPT would be half multiplied by 12.3 multiplied by 6. So 12.3 multiplied by 6, this is 73.8. So 73.8 divided by 2, this is 36.9. So area of triangle SPT is 36.9 units squared. This is how you get the answer for part B. All right, as simple as that. Simple sketch. Alternatively, we can use the area by shoestring method as well. So you can just give a pause to this video at this moment, attempt the area by shoestring method yourself and find the area. And after attempting it, you can see my solution. So I'll just do the alternative approach for part B, which is area by shoestring method. Okay, so coordinates of S are minus 2.5 comma 0. And coordinates of T are 9.8 comma 0, and coordinates of P are 5 comma 6, right? 5 comma 6. So the sequence is SPT. Okay, alternatively you can say STP as well. Okay, SPT means starting from S and then going up till point P and then point T and then S again, or you can say STP as well. So starting from S, then going at T and then coming at P and then S again. So you just need to complete the sequence. Okay, so here we have the three coordinates. So area is equals to half multiplied by, first you make the modulus sign. So S is minus 2.5 comma 0, then P is 5 comma 6. Okay, then T is 9.8 comma 0, and then the starting point again, which is minus 2.5 comma 0, and then you close the modulus sign over here. Okay, so area is equals to half multiplied by, first you make the modulus sign and then first you follow this zigzag pattern. Okay, so minus 2.5 times 6 is minus 15, and then plus 5 times 0, and then you have another 0 again, 9.8 multiplied by 0. And then the subtraction sign, and then you follow the opposite zigzag pattern. Okay, so 5 multiplied by 0 is 0, and then in your calculator you put 9.8 multiplied by 6, this is 58.8. So 58.8, and then minus 2.5 times 0, this is 0, and then you close the modulus sign. So area is equals to half multiplied by modulus of minus 15 minus 58.8. So minus 15 minus 58.8 is supposed to be minus 73.8. So half multiplied by modulus of minus 73.8, which means half multiplied by 73.8. So 73.8 divided by 2. This is 36.9 units squared. Okay, so in this way, we have found the area as well. Area by shoelace shoestring method. All right. So in this video, I've discussed two questions. This one was question number 20 of the handout, which is June 2017. C1 question number 8. And the earlier question was question number 14 of the handout, which was June 2012. C1 question number 9. All right. So I'll see you in my next video. Stay tuned to my channel. Thanks for watching. Assalamu alaikum.